All right, getting started. Welcome to is this day 2 or day 3 of 505, Antonio?
Day 3, sir.
Day 3. So, all right, so that means after this, you can go through the modules and then do your quiz. So we're going to go over multiplication on the complex plane, also called the Argand plane. And we learned that yesterday. All right, we're being recorded. Right, multiplying complex numbers. First, there is one fact that is true about the modulus when multiplying two complex numbers. P equals A plus BI and Q equals C plus DI. That is, the modulus of the product is equal to the product of the moduli. What? So, in other words, in simpler math words, because I think this is why I don't like English or geometry because it's very wordy. But with math, with all these fun words to explain what it is, I could just basically sum it up with this formula. So, in other words, the modulus of P times Q is equal to the product. Remember, product means multiplication. The product of the moduli. So, taking the modulus individually of P, the modulus of Q, and then multiplying together. So we're going to use this formula, and I would definitely write this down on your formula sheet. So I didn't create a formula sheet for Unit 5 just because there's not as many as there was in Unit 4. Unit 4, there's so many that I really thought it was important to organize it for you to save you the hassle, and I think it was helpful. All right, and before we go on, do any of you remember the formula? So if P is a complex number, A plus BI, how do I find the modulus of P? Anybody remember that equation? If you do, write it in chat. Yep, square root of A squared plus B squared. Very good. Very good. And I have that hidden under a white box. Tricky, I know. So hopefully all of you remember modulus and absolute value mean the same thing for complex numbers. So the modulus of complex number z is equal to the square root of a squared plus b squared. So remember that. All right, let's look at a couple examples here. All right, so first one on this page says two complex numbers, 2 minus 7i and 4 plus 3i are multiplied. What is the modulus of their product? All right, so we got two complex numbers. We want to know what the modulus of their product is. So how should I start this problem? Ideas in chat. Ideas. Ooh, so somebody says find the modulus of each. Okay. Solve each, find the modulus of each, and then okay. So Chloe's more specific, and I like her answer a little better just because she kind of expanded upon what to do next. So find the modulus of each, and once you have that, then multiply them together. Okay, I think that is a perfect way to do that problem. Anybody else have an idea? Or you could FOIL them, then solve for the mod. So then Emily says, well, or we could just multiply those complex numbers together, get that answer, and then find the modulus of that. So Emily and Chloe, they are both correct. So whatever you thought of first, do it that way, because there's two ways to do it. And I think my work on this page, I only do one way. But yes, there is two ways to do it. So going back to that previous page. So remember the equal sign. So we could do what Emily says and say multiply them together first, then find the modulus, or find the modulus individually and then multiply those answers. Either way is correct. We are going to get the same answer. And I kind of wish I would have shown the work for both of them. Whoops. Let me see. Hang on.
The less we know.
Yeah, I didn't do both ways. I just did one way. All right, so I'm going to give you all 3 minutes to do this problem. And do it either way you'd like. Either the way Chloe said or the way Emily said. 3 minutes, ready to go. When you do finish this problem, choose choice C as in cat when you finish. Just give me an idea who's done. Got about a minute left. So if you don't know if you're right, do it the other way. So if you were done early, feel free to do it the other way to compare answers. If you get the same answer, you probably did it right. Okay. So if you're still working, choose choice D, please. So at least I know you're here. D, if you're still working, see if you are done. Gives me an idea who's actually here. Let's see. Yeah, looks like most people are here. Looks like one person's not. Hmm. I know who's not here, but I won't call them out. Oh, they back. They back. All right. They're probably just finishing up. All right. In chat, what did you guys get for your answer? People that are able to finish, what did you get? 5 rad 53? 5 rad. Okay, a lot of 5 rad 53s. That sounds right. All right. So let me ask you this. So don't answer yet. Let me bring a poll up. All right. So if you did the Emily's way and you found the product of the complex numbers first and then found the modulus, choose A if you did it that way. And if you did it Chloe's idea of doing the modulus individually and then taking those answers and multiplying them together, choose B. Okay, so it's like split. Yeah, it looks like it's split. Some people haven't answered yet. Yep, so almost everyone's answered. Yeah, people need to stay focused when they come to live sessions. All right. So most people did it the way Chloe suggested of multiplying first and then find the modulus. But either way is fine. And from looks of chat, no matter how you did it, you got the same answers, right? Yep. So let me just show the work for that. I did it the way I multiplied them first together. First outer inner last, hit the FOIL it. I got that. Remember, I squared becomes -1. And -1 times -21 becomes +21. So let me just be thorough and show what I did. So this became -1. The -1 times negative is positive. Then we combine like terms to get this. And then from this point, I found the modulus of that product. So the modulus of 29 minus 22i, there's that. I type that in, I hit enter, and then I have the FX115 ES model, which is like $15 on Amazon, and it gave me radical form, which is 5 radical 53. If your calculator does not give you radical form, you must do it by hand. But you knew this. You knew this. Okay. Let's go on. Any questions on this one before we go on to the next example, which is a little longer? I'm just reading chat to make sure everyone's good. Okay. Looks like everyone's good. Okay. All right. We figured it out. All right. All right. Next example on this page says the product of two complex numbers is 6 plus 6i. So again, the product of two complex numbers. So we took a plus bi times a plus bi, whatever those numbers were, and we got 6 plus 6i. That's what that first sentence says. If one of the numbers is 4 minus 2i, what is the modulus of the other number? All right. So I would like all of you to think about it for a moment of how we can create the equation based on this information and using this formula all of you wrote down on your own paper because I don't have it in the next slide. So we want to use this formula and we want to plug stuff in from that word problem to set up our problem. So think about it. Think about what this problem is saying and see if you are able to set it up. All right. So if you think you know how to set it up, go ahead and write it in chat of the equation. And I don't want you to write like the square root of stuff. What I want you to do, when you plug this stuff into your formula, I want you to write it in this format. So this would be what you would write first before actually writing this in this form, if that makes sense. So we're just plugging this stuff into the formula um, in this form. So you shouldn't have any square roots yet, if that's what you're trying to jump to right away. Don't skip steps is what I'm trying to get at. So yeah, so how Julia wrote that out, not knowing if it's right or wrong yet, but yeah, that's what I want. Don't forget the absolute values, Antonio, because remember modulus is absolute value. You got to have those bars. Got to have those bars. Julia, do you think you can explain how you came to your answer? I know this stuff is not always easy to explain. All right. All right. So, Julia, I'm going to go ahead and show what you said so you can point to it. Oops. No. Pretend you didn't see any of that. Okay. I meant to click next, not delete that box. All right. All right, Julia, if you can try to explain with your pointer on mic, please.
Okay, can everybody hear me? And can you see the pointer? Okay, so the first sentence is that the product of two complex numbers is 6 plus 6i. So that's basically our first term on the left here is it's the modulus. So instead of that, I wrote the modulus of 6 plus 6i. And then we know that one of these, either p or q, is 4 minus 2i. So I just wrote the modulus of 4 minus 2i times x, or times a number written as a plus bi.
Perfect. Couldn't have said it better myself. All right, everyone follow everything she said and how she kind of just basically plugged it into the formula? So if you're reading the word problem and you are overwhelmed because you don't, you don't know the answer right away. Well, you're not supposed to. You're supposed to use the formula and plug in the stuff that it tells you to the formula. And then once you do that, it might become really clear what we need to do. So we plugged it in. And what should we do? So it says we must divide and conquer. Ooh, good idea. Divide and conquer. Now, maybe, so you can do what Antonio says, but you might want to save that step just to avoid fractions as long as possible. But it's not wrong. What Antonio suggested is not wrong. I just don't think it's probably the easiest to look at. So Caitlin says, could we convert the complex numbers into the moduli? Well, the answer is yes. So solve for the modulus first. So looking at this, we are able to find the modulus of this and the modulus of that. So everyone do that. Find those moduli. Moduli? Moduluses. Let's do 3 minutes to find those moduli for the next step. Yeah, remember those are absolute value bars. You can't combine like terms because it's like being stuck. It's kind of like being stuck in parentheses, but they're more stuck. Yeah, you can't combine like terms. Can't divide them. You can't multiply them when they're in the absolute value form. You have to do the calculation of that absolute value first before you can do anything else on the outside, if that makes sense. Got about a minute left. If you are finished already, choose C if you are done already. Choose choice C if you are done already. And then we'll just kind of sit tight until the time runs out. Who the heck chose A? It wasn't even an option. Unless you're AFK and now you're back and you just panicked and chose one. All right, time is up. If you're still working, choose D. If you're done, choose C. If you were AFK and you just picked one, well, shame on you. Yeah, Insta Twitter. What is the modulus for 6 plus 6i? What does that modulus equal to? Six rad 2, rad 72, 6 rad 2, 12 rad 2. So if you got rad 72, you need to simplify. So remember, so like Julia got rad 72. It's not simplified, so you're not finished, therefore it's wrong. That's the way I look at it. So, yep, rad 72 can be taken further. Yep, 6 rad 2. Yep, I agree. 6 rad 2. what did everyone get for this modulus? Two rad 5? 2 rad 5. I guess I have to show the work, huh? 2 rad 5. Yep, I agree. Okay, Antonio, what can we do next?
Divide.
Yes. Now we can divide. So everyone divide both sides by 2 rad 5. And now simplify that. Simplify this. So you can just type it in and hit enter and get the simplified answer, or you can do it by hand. Most of the time that I show the work by hand. So everyone do that. Can I simplify 6 and 2? So ignoring the radicals for right now. Can I reduce 6 and 2? Sure can. I can make that top of 3. So yep, 2 goes into 6 3 times. So that's what I did first. And then I rationalized by doing rad 5 over rad 5 multiplication. And then that gives us our final answer. So once we think we have a final answer, let's make sure we read the question again. Because sometimes, well, I actually say a lot of times on the TGA, a lot of you give me answers, but it makes me wonder if you even read the question. I'm like, does your answer what the question wanted? So simple cases was, please write your answer rounded to the nearest hundredths, and your answer is in radical form. And I'm like, oh, they didn't check to see what the question wanted. And I'm like, you could have got it right, but you got it wrong. But anyway, so this says, what is the modulus of the other number? The modulus of Q equals this. Did I answer the question? I sure did. So I'm done. That's the answer. Right. Yeah, these questions are different. Yeah, so in the previous, let me see what I did. I uncovered this box I didn't want to. Oh, and now it's not filled in. Everything's going right. Yeah, nothing to see here. Nothing to see here. Okay. Yeah, these numbers are very different. Yeah, very different. That's why word problems, they're really neat because they can be very similar, but the way you approach them very different. And that's why you need to be able to read word problems and really pick out what they're asking you to do and setting the question up correctly so you can answer it correctly. So, yeah, the more you do, that's why you should be doing the modules, learn and practice examples. Everyone should be doing those because I don't have enough examples in these lessons, and there's not enough time during these live sessions to get through lots of stuff. All right. On this other blue box, I did the problem differently. So I'm gonna show this, and then you can decide which way you like better, using that formula or using the way I'm about to show you. But spoiler alert: this way I'm about to show you is not very fun. Okay. All right. So the setup. The product of two complex numbers is 6 plus 6i. So here's the product. We have this number, this complex number times this complex number equals this. So we know that multiplying them together gives us 6 plus 6i. We know that one of the complex numbers is 4 minus 2i. We don't know the second complex number. So I set this up. And if you think about it, well, this actually makes a lot of sense doing it this way rather than use this formula. This formula makes it a lot easier math-wise, and you're going to see that in these next more than few steps. But this is what's going on, and not using the formula. All right, so next, remember, we're solving for Q. So Antonio, what should we do to both sides?
Divide.
Divide, yeah. So this is where we would divide to get this. Now, think about earlier this week. How do I simplify that fraction? Conjugate pairs, Emily says. Conjugate pairs. Anybody else agree with her? Multiply so we're going to multiply that fraction by the conjugate pair of that denominator. So we're going to multiply this fraction by 4. So what do I multiply by then? Top and bottom by what? 4 plus 2i. Very good. Yep, that's the conjugate pair. And why do we multiply by the conjugate pair? Like, what's the purpose of doing that? What does it do for us? It gets rid of the i's in our denominators. Yes. And that's why we do that. Yep. So I'm just going to show the work. You can just follow along. I'm not going to bore you to death because we only have about 20 minutes left. So we have to multiply this out, and don't forget that we're multiplying two binomials together. So that means we have this binomial times this binomial in the numerator, this binomial times this binomial in our denominator. So we do that. We, first, outer, inner, last, we do that. There's the work for it. And then this next step is I squared becomes -1. I didn't show it, but that's how that positive 12 became -12. And then on the bottom, that -4 became +4. Then 16 plus 4, that's 20, I think, on the bottom. And then that 24 and that -12 combined, those are like terms. So I get here. So remember, for complex number format, we need an A, and then we need the plus or minus bi, right? Right now, we just have stuff over a common, so you have to split it up. So we're going to rewrite this step and the next step as 12 over 20 and 36i over 20. So that's what we do next. And then you reduce it. 12 over 20 becomes 3/5. 36 over 20 becomes 9/5. All right, so now that we are in this format, so we can't stop here. My dogs are so needy right now. Oh my goodness. Hey, come here. Come on. All right. So we have to, so I lost my train of thought. The question wants us to know what the modulus of the other number. Now, this question could actually be kind of flipped around. What if I ask you, what is the other complex number? Ooh, what is the other complex number? If I asked you that question instead, could I have done this problem this way? Answer is a big no. Because the way that we did it the first way, this work gives us the modulus. There's nowhere in this work where we can actually identify what the other complex number is. We just know what the modulus is. And there's no way to go from modulus back to complex number format. It's not possible because there would be like an infinite number of solutions. So if this problem says what is the other complex number, we would be forced to do this problem this way. And then right here, we would stop. That means this right here tells us the other complex number is 3/5 plus 9/5 I. All right, is this clear? All right, so remember, word problems can just be so similar, but very, very different of how you approach them. All right, but because we want the modulus, we have to do the modulus of this. So that's what we do. Square root of a squared plus b squared. We set that up, and we just, we type all that stuff in, and we hit enter. And once you hit enter, you get, hey, weird, you get the same answer. Crazy, right? Crazy. So be careful on the word problems. If they want the modulus, we could do it this way. If they want to know what the other complex number is, well, we can't use this formula. We have to, well, do it this way. And this way doesn't look as fun as this way. All right, we good?
Wait, so you were just showing 2 ways on how to do the problem?
I was.
Oh.
All right, so after this point, I actually don't have any more examples. The rest of this lesson is going to go very quickly because it's mostly definition based. I have 6 more slides. Every slide is going over every single point here. All right, so scenarios of multiplying complex numbers. These are the 6 scenarios. We could do a real number times a real number. We could do a real number times imaginary. We can do imaginary times imaginary. We can do complex times real number, complex times imaginary, and complex times complex. So here's all the scenarios that we could deal with. All right, so the first one, real times real. So what we're used to, right? So real numbers, when b equals 0 and a equals 0, right? These are real numbers, no imaginary, no complex numbers. All right, so the 2 numbers lie on the real axis. So again, this is the Argand plane. Remember, this is the real. So horizontal is real, and then vertical, this is the imaginary. Okay, it's not x comma y. This is the Argand plane. All right, so if we have 2 real numbers multiplied by each other, well, the product is, well, real. So I color coded this. These, is that blue? It looks like blue to me. Is that blue? Okay. Is this green? Oh, it's yellow? All right, that's yellow. Okay, so the blue points are what we're multiplying together. The yellow point is the answer. So a real times a real is a real. Okay, that's the easy one. All right, a real times imaginary. So remember, imaginary and complex numbers are different. An imaginary number is a single term like I or I squared or I to the 3rd power, right? Actually, I squared would be -1, so that's actually not imaginary. Like I cubed, I to the 5th, I to the 7th, and so forth, right? So it has to be radical -1. That's imaginary. Complex numbers include imaginary, but you have a real plus, a plus bi. So it's in that form. So they're different. Make sure you know the difference. All right. So real times imaginary.
Would i's with coefficients, would those be considered just imaginary numbers, or would they be considered complex numbers?
Nope, these are imaginary because it's in the form of just, these are just a scalar. So yeah, it's just imaginary.
Perfect. Thank you.
All right, so we have a real times imaginary. What this does when you have a real times an imaginary, it causes a 90-degree counterclockwise rotation. So from here, it rotates 90 degrees. That's what that does. And so there's that first example when you have 2 times I. And then for this one down here, we have -3 times I. So there's -3, there's I. So it causes a 90-degree counterclockwise rotation. Case 3. Imaginary times imaginary. All right. Since I squared equals -1, the imaginary component cancels out to become a real number. And I said that a slide or two ago. All right, so this means that the productive results in a 90-degree counterclockwise rotation onto a real axis. So we're talking about imaginary times imaginary, so I times I. I squared is -1, it becomes real. There's these two imaginary numbers. We have I and 4i. Here's I, here's 4i. So this times this causes a counterclockwise rotation to become a real number. And then looking at this example here, we have -3i times 2i. This causes a counterclockwise rotation to become a real number. All right, we good on this page? Now, I don't expect anybody to memorize all of these cases, but you should have the notes to go back to if you need to for quizzes or whatnot. Okay. If I don't have memorized, I don't expect any of you to have it memorized. Now, you could probably think of it and then figure it out just by kind of thinking through it, but not that important to memorize this stuff, in my opinion. All right, case 4, complex times a real number. All right, so it results in a scalar multiplication of the complex number. In other words, the new complex number is in the same direction. We haven't learned about vectors yet. Same direction as the old, but well, further from the origin. For example, we have 3 times 2 plus I. So we have a real number times a complex number. What that does is this causes this to just be in the same direction. So if I did a straight line, let me get my line tool out. If I drew a line from the origin, I would go through those points. Everyone see that? So it's same direction from the origin, just well further out. That's what a real times the complex number does. Number 5. Right, complex times imaginary. So as we have seen before, imaginary numbers cause a 90-degree counterclockwise rotation. This is also true even when multiplying by a complex number. So for example, we have I times 4 minus 2i. So imaginary times a complex number. There's the imaginary, there's the complex number. So this causes this to rotate 90 degrees counterclockwise. So if you notice, there's a pattern. We pretty much, if there's a rotation, it's always counterclockwise. No one seeing the typo. Where's the typo?
You put a V instead of a Y.
You know what? It's the graph is covering it. Let me go to that slide and fix it. Yeah, let's send this graph to back. Thank you for pointing that out so I can fix it.
You're welcome.
All right, and the final case, complex times complex. So because complex numbers consist of both real and imaginary parts, a product of complex numbers will result in both a rotation and a scalar multiplication. So you're going to cause a rotation, and it's going to be further from the origin, or in other words, it's going to have a larger modulus, right? For example, we have 2 minus 3i times 1 minus i. So there's the work. So we have this times this, and this one actually causes a clockwise rotation, and then it's further from the origin from the original. So for these, you're going to actually have to just do the math. You know, I couldn't tell you if it's going to rotate clockwise or counterclockwise. It really depends on the original complex numbers. So it is possible to rotate either direction depending on what these values are. Other than that, any questions? Just definitions, guys. That's all it is. And on your quiz, you're just going to ask you questions like, you know, what happens? What's the transformation you do if you have this type times this type? And you just go to these, you know, these slides, definitions, and it tells you what happens. You can have the slides. Yep. So let me post those. And as always, guys, thanks for coming, and I hope you learned something. And I will see you next week at, well, between 4 and 4:30 probably, but hopefully you can make it because of the AIMS testing. Oh, and don't forget, locking date for Unit 4 is on Sunday. So get her done.